Hi there and welcome grade 11 Mindsets. It's finally is your turn, and as you can see, I've got a comedian slash teacher. Peter is back in action. We've missed you, Pete.
Oh, I don't know why you've missed me. I've missed you. You haven't been around for, 5, 6, 7 months now. It's
No,
been
I
quite a
have.
while.
I have, guys. They'll tell you that I have been here.
Really?
You've just been missing me, you know? Like
When
different
you're on, I'm
days.
off, and when I'm
Yeah,
off,
exactly.
I can
exactly.
understand that, but I'm sure the viewers understand why we do this.
Yeah.
All
yeah.
right. Great week for you.
Brilliant week for me.
Enjoying the Olympics.
Loving the Olympics. I love
Fantastic.
the
So far,
Olympics.
5 medals as we talk today, which is absolutely exciting. Great weather on Tuesday.
Snowing.
And
Hey.
apparently, history has it, it's the first time it snowed on the same day in every province.
Really?
Yeah,
not
can
even,
you believe it?
Not even in 1961. When was
Well,
the
I
last
don't
time
know when
it
they ever
snowed?
recorded it. I don't know, but apparently
Hey.
that's what I've heard.
Incredible. How many of you guys saw the snow? Let us know.
Let us know. I'm
But-
going there.
No,
You
but
tell
what
them
you're
about
going to
this.
do, you're going to tell them first what we're going over. So it's 2D and 3D measurements.
It is
All
indeed.
very
And guys,
exciting.
here's the great, exciting thing. We're only doing one question today. That's given our producer quite a fright. Eh?
Is that
She's
exciting?
got ads ready because she doesn't know what's in store for us today. But guys, one question today, but it's a phenomenal question. In fact, it's a portfolio piece that I gave my grade 11s earlier this year. So it's well worth having a look at. I think it's great because
So
it
that
involves
sounds
so
mean.
many things.
That sounds like a mean question.
I know, especially when you walk into your class and you say to your students, you only got one question to do today. But it's
For
got
an hour,
like
for
30
an hour,
points. Yeah,
Hey?
parts to it.
An hour lesson. Oh,
I'm going.
Guys, it's going to be amazing. I'm telling you, we're going to have such fun. So what you need to do is you need to chat to me, Indiana, on Facebook, facebook.com/learn extra. You can also chat to me on Twitter @learn extra. If there's anything that you are struggling with, please post it on the page so we can help you in the last 15 minutes of the show. So now I'm going to pass it over to Peter, and we're going to have an awesome lesson. I'm pretty excited. Pete, take it away.
All right, folks. So it's 2D and 3D measurements. All right. So this is the task that was given to my students earlier this year. Quite simply, your school wants to build a swimming pool. And we are going to find out how much it actually cost us to dig the hole, to get the soil out of that hole, obviously, right? I suppose you've got to get the soil out, otherwise it's not a hole, is it? Yeah. Okay, so we got a ground. We're going to dig in. We're going to pull out some soil, and so we're going to be left with the hole. We've got to get rid of that soil. Then we've got this lovely big hole. We've got to line it with some concrete, right? And then we've got to fill it with water. The question is going to be ultimately, how much does this project cost us? So let's have a look at the question straight away. Okay. Now, a school is to build a swimming pool with these dimensions: 25 meters long, 10 meters wide, 1.5 meters deep on average. Let's just stop there for a minute. Now, obviously, you're aware that sometimes a swimming pool doesn't have an equal depth throughout, right? You might have a pool that's got a shallow side, and then it's got a deep side. But on average, we're saying that the depth is 1.5 meters deep. Do we understand that? Okay, let me draw it for you here. So let's pretend that we've got a pool like that. Can you see that? So this part might be 1 meter deep, and this part here might be 2 meters deep, but the average depth is round about 1.5 meters. Do we understand that? So I've actually made the question kind of easy, because now you're not trying to work with a weird looking shaped pool, but you're going to pretend it's a rectangular pool. Okay? So it's got a depth of 1.5 meters, even though it doesn't. Some's 1 meter, some's 2 meter, but on average 1.5 meters. Now, the following information is also going to be useful to us. No heavy machinery can be taken to the site, so everything has to be done by hand. The density of the soil at the school is 1.6 grams per centimeters cubed. The volume of the soil that can be put into a wheelbarrow is 0.8 meters cubed. A worker can fill and move 12 wheelbarrows per hour. A skip can hold 9,2 meters cubed of soil. They cost 1,750 Rand per day to hire. What's a skip, folk? A skip is one of those huge metal containers. And you can just throw a whole lot of rubbish inside there. Okay, in this case, we're not throwing rubbish. We're going to be throwing soil inside that skip. All right, so you all know what a skip is, hey? That big metal container. Normally, they get picked up and put on the back of a truck, and the truck takes the container off. Got that? And that costs us 1,750 Rand per day to hire. We're told there are 2 workers who each work for 6 hours per day at a cost of 200 Rand each. A local businesswoman has donated the pump and filtration system worth 12,500 Rand. Sure, that is a lot of information that's just been given to you. A whack of information. Now, let me just tell you this. If you were given this kind of question in an exam, whether it's at the end of the year, whether it's a class test, even if it's at the end of the year, they wouldn't just pump all this information on one sheet. Normally what the examiner would do is he would ask a question and then give the information that you require for that. And then you're able to answer it. Then he'll ask you another question, give you a bit more information, and then you could answer that question as well. But that's all the information we need. Now, let's get on with our very first question. So, question number 1 states the following. How much soil will there be in meters cubed? So there's a bit of information that we need. And we need the following information. Okay? We need to know the actual length, the breadth, and the height of that hole. Because once we know the length, the breadth, and the height of the hole, we'll be able to determine how much soil is actually in that hole. Right, so if you remember correctly then, how do we know the volume of a rectangle? We are going to say that the volume is equal to length times the breadth times my height. Now, what is my length? What's my breadth? What's my height? Let's go back to all that information. We can say we've got a length of 25 meters. We have a width of 10. So let's write that down straight away. We've got a length of 25 meters, a breadth of, what did we say, 10 meters, and an average height of 1,5 meters. Let's just confirm that. So we're saying 25 and 10, 25, 10, and 1,5. Absolutely excellent. All right, so now, we're dealing with volume, guys. I know if I'm dealing with volume, my units at the end have to be units cubed. If I was dealing in area, it would be units squared. And if I was just dealing with perimeter, I would have just plain units, like meters. Area, meters squared. Volume, meters cubed. And we're dealing in volume. So we know it's going to be meters cubed. And so it's not a bad thing to write here already, meters cubed. So before I've even solved the problem, before I've even pushed buttons on a calculator, I know my answer is going to be meters cubed. So out comes our calculator, and we're going to say, right, 25 multiplied by 10 multiplied by 1.5. And we get an answer then of 375. So 375 meters cubed. Right, now every single week I sit here or stand here and work, and Indiana just sits and types away on a computer.
I pretty much have fun. I get to chat to everyone, and I get to be social, and you get to teach. It's important. You need to teach.
What she's trying to say, she does nothing. So, this question is going to require me to keep getting information from previous questions. So, Indiana, I need you to type this kind of thing down.
I see where this is going, Peter.
You see where this is going. Get out a Word document and let's go for it. The volume, 375. Got that? Mm-hmm. Sure, we're making progress. Right, let's go on to our next question.
Hard work this, yeah, Peter.
Our next question. How many wheelbarrows worth of soil is that? All right, so now we've got to know if I have a volume of 375 meters cubed, okay? So we know then that my volume, let's get a nice color pen, my volume is going to be 375. Is that right, Indiana?
That is absolutely correct.
Cool.
Well done.
And we know as well that when I go back and have a look here, one wheelbarrow is, what did it say? The volume of soil that can be put in a wheelbarrow is 0.8. So I know that each wheelbarrow is 0.8 meters cubed. So if I divide this by 0.8 meters cubed, it's going to tell me how many wheelbarrows I need. Let's go through that again. All the soil comes to 375 meters cubed. I need to take a little bit out and put it in the wheelbarrow. How much do I need to take out? Well, I can only take out 0.8 meter cubed worth of soil. Put it in the wheelbarrow, okay? And off you go with the wheelbarrow, pushing it away. Then you come back, you see, and you get another wheelbarrow, and you put in another 0.8 meter cubed of soil. And you push the wheelbarrow, and off you go. And then you come back, you see, I haven't gone away, I'm back. And you come back and you put more. Now, how many times do we have to carry this wheelbarrow? Well, I've got 375 meters cubed, taking out 0.8 meters cubed. Let's see how many we need. So all I'm going to say then on my calculator is this. 375 divided by 0.8 equals, and we land up, now I want us to take notice of this, 468,75. 468.75. 468.75 what? Wheelbarrows. Okay. Now, gentlemen, you can't take 0.75 of a wheelbarrow. Okay? You can fill up a wheelbarrow 3/4 full, but you can't take 3/4 of a wheelbarrow. So I can't have my wheelbarrow and say, right, I'm only going to take a little bit of this wheelbarrow, so I'm going to cut off 1/4 of it, pick up the back part, and off I go. That's just totally stupid. I've got to take the whole wheelbarrow. And so what I'm saying is this, instead of 468, I'm going to take 469 wheelbarrows. Got that? Easy? I hope so. Producer was saying something in my ear. Was she calling for an ad break? Was she?
Okay, I don't know.
Oh,
no, she wasn't. She wasn't.
Okay, right. All right, let's move on. So, now, what is the mass of the soil in kilograms? You may use the following formula. The mass is equal to the density times the volume. Now, take note here, folk. They're actually giving us a formula. And remember what I've always said. Now, we say this to the grade 10s. We're saying it to you now, the grade 11s. And let me break some good news to you. Next year, when you're in grade 12, we're going to be saying the same thing to you as well. If you get given a formula, use it. Right? There's no point in an examiner giving you formulas if you're not going to use them. So, I see a formula and I say to myself, I must use this formula. And that's what we're going to do. So I know the mass, and we asked to calculate that mass, and there it is there, is equal to the density. Wait, what's the density? Are we given the density at all? Yes, we are. If we go right back to our bit of information that was given to us earlier. In fact, I've got it on another sheet here. Here we go. How good is this? Right. So, if we go right back, we get told that the density of the soil is 1,6 grams. Let's have a look at it. 1,6 grams per centimeter cubed. Okay? 1.6 grams per centimeter cubed. Now, let's go to our formula. And our formula density, and we said it's going to be 1 let's get a
6
pen.
grams
1,6 grams per
centimeter cubed.
centimeter cubed. Good. Times the volume. Now, times the volume of what? Times the volume of soil. Now, Indiana,
I'm scared,
your
yes.
answer was, remember we worked out
Of
the
soil.
volume?
Oh my gosh.
300 and?
Wasn't it 469 wheelbarrows?
No, not the wheelbarrows, the density of the soil. Okay,
Oh, no, go
remember, it
back,
was
Peter.
375 centimeters.
Ah.
Okay, do you remember that?
I understand. Yes, I
Okay,
remember
in fact,
that.
it wasn't centimeters, it was 375 meters cubed.
Cubed.
Oops, there we go, where's my pen gone? Okay, meters cubed. I have a huge problem here, gentlemen and ladies.
Yes, don't
And
forget the
that's
ladies,
this.
especially it's Women's Day. Peter, you better, thin line.
It is Women's
It
Day.
is.
This is why we've had a wonderful holiday today.
I know. Thank
know.
goodness for women.
All right. So, ladies and gentlemen, the problem we have is this, that we are dealing with centimeters cubed over here. Let me get another color so you can actually see this. Centimeters cubed here, but here we got meters cubed. Now, we've got a problem. We've got to get the units to be the same. So I'm going to have the density in meters cubed and the volume in meters cubed. Or I'm going to have the density in centimeters cubed, but then the volume also has to be centimeters cubed. Okay? They have to be the same. And let me show you why. What we're going to have is this. If I have grams, now do you know what the slash means? In other words, for that slash is per. So it's 1,6 grams per centimeter cubed. In other words, if I got a little box and it was 1 centimeter high, 1 centimeter long, and 1 centimeter wide, tiny little box, and I filled it with soil, that soil would weigh 1,6 grams. Sure, tiny little bit of soil. But we're not dealing with tiny little centimeters of soil. We're dealing with meters of soil. Right. So if I've got an area a meter wide, a meter long, and a meter high, what's the weight of that soil? So what we're going to do is say, you know what? Let's change all our units to the same thing. So if I'm measuring what's the weight in a meter, then we need to change that to meters. Or if I'm going to keep it centimeters, we got to change my meters cubed to centimeters. And that's exactly what I'm going to do here. So I'm going to say I've got 1,6 grams per centimeter cubed. Now I'm going to change this 375 to centimeters. Okay? Now, how do we change meters into centimeters? Well, how many centimeters are in a meter? There are 100. Agreed? But because I'm cubing, it means I've got 100 this way, 100 this way, and 100 extra this way, or 100 times more in my height as well. So it's 100 times more in my length, 100 times more in my breadth, and 100 times more in my height, because it's volume. So I'm going to say it's equal to 375 times. There are 100 centimeters in a meter. But we're not just dealing with centimeters and meters, we're dealing cubed. And cubed means I've got 3 of these things. Okay, because it's got 100 times more in the length, 100 times more in the breadth, and 100 times more in the height. And that will now be centimeters cubed. Equals. So now what have I got? 1,6 grams per centimeter cubed multiplied by. Now, let's bring out our calculator and have a look. With my calculator, we're going to say, cool, I've got 1.6. Let's try that again. Whoopsie. Okay. Okay, calculator has frozen on us. Why does a calculator have to freeze on us?
Oh,
Why do you
shame,
think it
Peter.
happens?
Shame.
I think maybe that's a gremlin saying we need to take an
Exactly.
ad break.
Exactly. So can I take it to ad break?
Let's take it
You
to
see
ad
how
break
he
and I'll
likes to
fix
do
up
my
the
job.
calculator
He
for
likes to do my job. I'll let him do his job. Guys, we're going to take a quick break. See you now. Hi guys and welcome back. Everything's sorted out and the lesson is on track. Peter, I actually have a question on the page for you. So we might as well. Hey, what do you think?
Okay.
Be kind. Okay, from Takalani. Takalani says, so Peter, what if they didn't tell us to change to meters or centimeters? How do I know that I must change it to meters?
Okay, Takalani, that's a good question. This was kind of a horrible question I gave you. I think the one thing you've got to look at is normally we would give you a length in meters, a breadth in centimeters, and another one, let's say, in millimeters, and then you would be expected to change it. I think if I was setting your exam at the end of the year, for this kind of thing, I wouldn't be so mean. I wouldn't give you a horrible question like that, mainly because this is a maths lit question and it's not a science question. If it was a physics question, then you'd be expected to know that. And there's no way we can expect people who don't do physics to understand that. Okay? So please don't get too worried about that. But to answer your question anyhow, what you would do is if you saw you've got, like, for example, grams per, basically means I've got grams per means divided by centimeters cubed, okay, times and meters cubed. All right. Now, there's no way I can cancel my centimeters cubed with my meters cubed. But if I change both of them to centimeters cubed and centimeters cubed, then my final answer will be as a mass. It would be grams. Okay? That's the horrible mathematics behind it. But like I said to you, being math lit, the question is on the mathematics, not so much the physics part of it. So in a final exam, I would probably have told you that remember to change that to centimeters cubed, or I would have asked you to calculate the volume of the soil in centimeters cubed in the first place. All right? So don't panic too much about that one. It is a horrible question. It was out there to catch my students, but remember, they were doing it as a portfolio piece. So they could use a few books to answer their question. They could use resources. They could use a lot more time than what would be required in a test. So I did make that part of the question a little bit ugly. All right, but let's move on.
So mean.
I am mean, it's true. My students would agree with you. All right, now, times. Let's move on. Now, my calculator, it's working. We found out what the problem was. The problem was, when you use this calculator, you can't use the pen. You've got to use your finger. Okay, and but Indiana told me to use the pen, and that's why it went wrong.
Sabotage.
Right. Okay, so here we go. So remember, we are now saying 375 multiplied by 100 because we're changing the centimeters, the meters to centimeters. But because it's cubed, we're going to do it 3 times. Times 100 times 100 again equals, and there's my answer. Yeah, all those noughts. 1, 2, 3, 1, 2, 3, got 6 noughts. So I'm going to land up here then with 375 million, because we've got 6 noughts, what? Centimeters cubed. Okay? That's how many little centimeter cubes. So if I made a little box, 1 centimeter, 1 centimeter high, 1 centimeter long, 1 centimeter wide, I would need 375 million of them to get all the soil out the hole. That's a lot of little cubes. All right. Now, let's multiply. So we got 1,6 multiplied by that answer. So all I'm going to do is I've got my answer. I'm going to say times 1.6 equals, and there it is. 1, 2, 3, 1, 2, 3, 1. So 600 million what? Grams. 600 million grams. But we're not finished with that question. Why are we not finished with the question? Guys, let's read the question. It says, what is the mass? But we found the mass. So what's the problem? Of the soil in kilograms. Okay. So we've got 600 million grams. And we now got to change it to kilograms. Guys, how many grams in a kilogram? There are, Indiana, do you remember from your school days?
Sure, 100?
Absolutely wrong. There are 1,000. Okay, so we got 1,000 grams, so we're going to divide this by 1,000. And when we divide it by 1,000, our answer is 600 20,000 kilograms of soil. That's a huge mass.
That's a lot of soil.
That's a lot of soil. I mean, that's quite a lot of me.
Yeah.
to
How many
carry.
of yous is there? Maybe we should add that as a question.
Should
How
we do
many is
that
of
as a challenge
Peters?
question? How many of me is 600,000 kilograms?
But now is
Sure.
this estimation now? Hey,
No,
we're going to
let's
have to
not go
find out
there.
how
Let's
much you
not go
weigh
there. It's
first.
gonna get embarrassing. Let's go on to the next question instead. Right, next question.
You're a
Yes.
scaredy cat.
I am. It's absolutely true. Now, how long will it take our 2 workers to dig out the soil and get rid of it? Right, so now remember, look how this information's just come up on the board here. It's
That
magic,
was
okay?
fancy.
A worker can fill and move 12 wheelbarrows per hour. So how long will it take our 2 workers to dig out the soil and get rid of it?
Shem, I feel sorry for these 2 guys.
Okay. How many wheelbarrows did we need? Do you remember that?
Hold on, let me check my
I think
notes
you've got
here.
it back
I
there.
think how many wheelbarrows did we need?
469.
68. No, 469. You're
That's
right.
right.
You're
I
right.
am right.
You
Thank
you
you.
are
I am
right.
absolutely-
I had
and I did
another
that all by myself.
amount. Yeah, you did. Well done.
469 wheelbarrows are required. Now, 2 workers are going to work on it, and we're told that a worker can fill and move 12 wheelbarrows per hour. So how many wheelbarrows can we move in 1 hour? Well, we know that a worker can move 12 wheelbarrows, okay, for every hour. But if we've got 2 workers, folk, how many wheelbarrows are we moving in an hour then? Well, one is moving 12, another one is moving 12, so we're actually moving 24 wheelbarrows every single hour. Okay, so how are we going to calculate this? Well, we're going to say if we got 469 wheelbarrows, let's divide this by 24 wheelbarrows. And that'll tell us how many hours we actually need to move all the soil. Okay, I think it's going to take quite a few hours. What do you think,
I
Indiana?
think it's going to take very long.
Okay, let's go for it. So on our calculator, we are going to say, right, we've got 469 wheelbarrows. We're dividing it by 24, because 24 are going every hour. And voila, there we have 19.54 hours. Okay. Now, Indiana, I want to ask you something, because
I know exactly what you're going to ask.
Oh, you're gonna
I
ask.
think I'm ready.
Okay.
Carry on.
So it's 19 hours and how many minutes?
Sure. Oh my gosh. 54?
54. Absolutely wrong. And so many matrix make that mistake. They say 19,54 hours means 19 minutes and 19 hours and 54 minutes. Guys, it doesn't mean that at all. Why not? Because how many minutes are in an hour? There are 60 minutes in an hour. So this 54 is 54 over 100. But we've got to convert it to over 60 because there's 60 minutes. So please don't fall for that, okay? Just do not fall for that. What we're actually saying is 0.54 times 60. And that will tell us how many minutes. So how many hours and how many minutes. But guys, the question wasn't how many minutes. We're not even getting that complicated. We want to know how many hours in total are going to be worked to move that soil. And if it's 19,5, and you're paying your worker by the hour, he's got to work into that 20th hour. So he's worked a full 19 hours, but there's still some soil left. He's still got to move a little bit more. And he's not working for the full hour. He's only working 0.54 of an hour, okay? So he's not working the full hour, but you still got to pay him for that. So how many hours? 19,54 means 20 hours. So he's going to work, or both workers are going to work 20 hours. Right. Next question. This is quite a nice exercise, isn't it?
Yeah, it is. Except my thing is that shame you can never make somebody work 20 hours a day. So
but we
obviously,
didn't say
you know,
that. No,
8 hours a
no.
day.
We
So
didn't-
2 days.
We didn't say. We didn't
He's
say
trying
he's
so
gonna
hard,
work.
guys. He's trying so hard.
We didn't say the guy's going to start working and we're going to say, you keep working until this job is done, okay? It's not my wife, right? It's a normal, loving human being who says, please do the job You can only work 8 hours a day, so off you go. But how many hours in total is it going to take? He doesn't have to start the job and end the job, and he's not allowed to have a break.
Okay, good. Because I just worry about people, but that's cool.
All right. If it was my wife and she was talking to me, she'd say, you start, and don't you dare stop until it's finished, boy. All right. But we're not like that. Right, let's move on. By the way, my wife's a wonderful person, I must tell you.
She's
She
lovely, and
really
I've
is.
met
And
her
I'm just
too. I've met
pretending,
her
and that's
too.
why they say you only tease those you love. That's why I don't tease you at all. All right, let's move on. Okay, next one. How much will it cost to get rid of the soil? Remember to include the wages of the workers and the skip hire. Okay, so what we're going to do is we are going to try and find out all the information we possibly can, and let's have a look at this. So a skip can hold 9.2 meter cubed of soil, and they cost 1,750 per day to hire. Okay. There are 2 workers who each work for 6 hours per day at a cost of 200 Rand per day each. Right. Now, let's look at this part first, because we've just been talking about our workers. Right. And we said our workers, we need them to work for a total of 20 hours each in order to move all that soil. So they work 200 Rand per day each, but they can only work for 6 hours a day. So how many days are these guys actually going to work for? Well, let's have a look at it. Day 1, 6 hours. Day 2, 6 hours. So far, what have we got? We got a total of 12 hours, right? Do we need to still work? Yeah, we do, because we've got to get to 20. So day 3, another 6 hours. That now gives me a total of 18 hours. Do we still have to work? Yes, we do have to work, because we've only done 18 hours of work and we need 20 hours to get all that soil. So we've got to put in another 2 hours. Right? And that's going to give me my 20 hours. But I've said to my workers, listen guys, we are paying you 200 Rand a day. Okay? So they've worked for a full day, that's 200 Rand. They've worked for another day, that's 200 Rand. They've worked 6 hours on the third day, that's 200 Rand. Day 4, they have only worked 2 hours. They have not worked a full day. But, these guys have still had to come to work, and they've had to work for some of that day. And the question did not say that if they're going to be paid per hour. If the question said they were being paid per hour, then we could say, hey guys, day 4 you only work 2 hours, so we're only going to pay you for those 2 hours. But this question doesn't say it, does it? It says they're paid for a day's work. So even though they've worked 2 hours, they're going to be paid the 200 Rand. Okay? And one would presume that they're not just going to fill up the wheelbarrows and when they finish say, cool, my work's done, and off they go. They're going to have to take the wheelbarrows, they're going to have to clean them, they're going to have to clean the spades. It's not going to quite be 2 hours, but we're paying them for the day. So how many days have they worked? We're going to say in total, these guys have worked 4 days. And 4 times 200 is going to be a total of 800 Rand for the day's work. Or for all their work in carrying that soil on the wheelbarrow. Okay, happy?
Very happy.
Let's move on. And you, of course, in the end, are taking all these down, so when we refer back to them...
Some of them, Peter, some of them. You need to indicate which ones.
Right, so next one. Once the hole has been dug, let's just do this quickly. Okay, so now, once the hole has been dug, we need to line that pool with concrete to make it watertight. What surface area do we have to cover? All right, now folk, what we're going to do is this. We know the dimensions of the pool. Our pool is 25 meters long, 10 meters wide, and 1.5 meters deep on average. We are trying to find the surface area of that whole pool. How much area needs to be covered? Okay, let's read the question again.
I want to ask
Yeah.
a Peter about the skip. A question about the skip. What was my question again? It said to include the skip costs.
Oh, in the previous question.
Yeah.
Oh, that's right. I got so
Yeah.
excited about this, I forgot about the other part of it.
Yes, Peter.
So how much will it remember to include the wages of the workers and the skip hire? Ah, okay. And remember, if we remember correctly as well, we said that the skip hire was 1,000. I've got it here somewhere. Thank you for that. Thank you for that.
It's a pleasure. It's a pleasure.
So we
Peter.
told a skip can hold 9.2 meter cubed of soil, okay, and they cost 1,750 rand per day to hire. Now, I'm not going to worry too much about this thing because we know that every day these guys are only carrying 6 wheelbarrows, or rather working for 6 hours. So how many days have they worked for? We said 4 days.
Yeah.
Okay. But what we need to know is how many skips did we need to fill up, to put the soil in? Right. So how many skips were needed in order to put all that soil in? Okay. Can you remember this for me? 9.2?
Got it?
Got it? Okay, cool. Now, let's go back here. So what we're now saying is this, that if I have 9.2, what was it? 9.2 meters cubed.
Meters cubed, yeah.
Yeah, okay. And we had a total of how much soil? 375 meters cubed of soil. Okay. How many skips does that mean I need? So we're going to say, well, 375 divided by 9.2 means I need 40,7 skips. In other words, 41 skips. So we need 41 skips was required. Oh my goodness, writing just appeared here. Okay, so we needed 41 skips. And if each skip cost us 1,750 rand to hire.
That was brilliant, correct.
Okay, then we've got to multiply that. Do you agree with me?
I agree.
Okay. So we now say 1,750 times the 41. If we can get our calculator, here we go. Right, so we've got 41 times, what did we say? 1,750. So the skip's costing us 71,750 rand.
Sure.
For them to get the soil and take it away. Sure, that's a lot of money. Hey?
That is a lot of money.
A lot of money. All right. And then we'll add it to the wages. Got
Awesome.
that? And remember, each guy gets 800 rand. So it's the 71,750 for the skip, plus the 800 for the one chap to work, plus 800 for the other chap to work, and that will then give us our final total.
Okay, so that's not the final total now.
No, because it's 7150 plus the 800 rand for the first guy, plus the 800 rand for the second guy.
Equals
73,350 rand.
the price of a really nice second-hand car.
Basically.
Yes,
Okay.
exactly. Okay, Peter, how's about a break?
Is it a time? Let's take a break.
Let's do it. Okay, guys, we're going to take a quick break. We'll see you now. Hi guys, and welcome back. Before we start, I just want to say congratulations to Bridget Hartley, who's a female canoeist who won a bronze South African medal for South Africa in the Olympics and on Women's Day too. We are so proud of you. Well done. And I think we're going to go straight to Peter. I can see he's going. He wants to carry on with his lesson. What's
no,
not a
not
joke?
at all. I just think it's
Tell a
wonderful
joke.
news that we're busy getting all these medals, which is absolutely fantastic. All right. Guys, we had now dug our hole. Remember, our workers had taken all the soil, they'd loaded the wheelbarrows, taken all the soil, put it in a skip. We came up with this ridiculous amount of money that it's going to cost us to actually just dig the hole and get the soil out. And now what we're going to do is we're now going to line this pool with concrete. Okay, or the hole rather, with concrete. And so the first thing we need to do is work out the surface area of that hole. Right, so folk, what are we doing? If we were to look at a box, all right, and we were then to say, well, if I look on the inside of the box, what's going to happen is this. I've got the edge, or the one side of the box, right? There it is there. Then I've got the breadth of that box. There it is there. Okay? And then I've got the bottom of that box. And I'm just going to do it in a different color so you can see it. Let's go. Dum, 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 dum. Oops, I missed. I went wrong. Okay. But there's the bottom now of that box as well. So looking at it, I've got a side and the other side, the length. I've got the one breadth and the other breadth, and then I've got the bottom. So I'm going to put concrete on this side and this side, concrete on this length and this length, and then concrete at the bottom. Now I'm not going to put concrete on top. Okay? You don't want concrete on top of you. You know you got a problem if you got concrete on top of you. All right, the mafia have been to visit. So it's only concrete at the bottom, concrete this side, this side, and behind me. So let's find out now the surface area of that box. We know that if I had to look at this side here, there it is there. We're told it's 25 meters long and on average 1,5 meters high. So the area of that, and it's a rectangle, hey? So it's going to be length times breadth. And the length is 25 meters. And the breadth, well, in this case, it's the height, but is 1,5 meters. And I'm going to say that times 2. Why times 2, folk? Because I've got 2 length sides, right? One this side of my swimming pool and one that side of my swimming pool. Got it? I feel like an air hostess. Evacuate here.
Only one to one click. One click.
Right, here we go. So, on my calculator then, we've got 1.5 multiplied by 25 multiplied by 2 because there are 2 of those sides, and I get 75 meters what? 75 meters squared. Right, now that's the total surface area of both my lengths. What's the surface area of my breadths? Well, let's have a look at it. So the surface area of that part there, can you see it's in the shape of a rectangle? But this now is my breadth, and we know it's 10 meters. The height is still 1,5 meters. So what's my area? My area is going to be 10 meters times 1,5 meters. And again, I'm going to say, you know what? I've got 2 of those things. So let's do that on my calculator. So with my calculator, we have got 10 times 1.5 times 2, because there are 2 of them, equals 30. So I've got an answer now of 30 meters squared. Now, all I've got to do is find the surface area of the bottom of my pool. So if I'm looking from the top, this is what I'm going to see. Okay, and I know this is 25 meters long and a breadth of 10 meters wide. So my area is going to be 25 meters multiplied by 10 meters. Am I timesing it by 2? No, I'm not. Why not? Because I'm only got the bottom. I don't want to concrete myself, okay, on the top. When I multiply that out, I'm going to land up with 250 meters squared. So now, what's my total surface area? The total is going to be the 75 over here. Let's go to a different color. We'll go pink because it's Ladies' Day. 75 meters squared, 30 meters squared, and 250 meters squared. So 75 meters squared plus 30 meters squared plus 250 meters squared equals. And now we're just doing this on our calculator. And we're going to say, right, we've got the 75 plus the 30 plus the 250. 75 plus 30 plus 250 is 355. Okay, equals 355 meters squared. That is the total surface area of the pool. In other words, that's the area that I'm going to need to concrete in my pool, right? Plus the bottom. Happy? Let's go on to our very next question. Right, and the concrete has to be 5 centimeters thick. What is the volume of concrete that we need? Now guys, whenever we do volume, we know that volume is equal to the area times the thickness or the depth. Okay? Equals the area, and we just calculated it. Let's go back to it. Where was it? Here it is, 355. So it's 355 meters cubed. Sorry, squared, because we're dealing in area. Okay? Times a thickness of 5 centimeters. Now, folk, my problem is this. I can't just take my calculator, hey, and say 355 times 5. Why? Because the one's in meters cubed and the other is in centimeter. So I've got to get the same unit. Do I know what unit I need? Doesn't tell us, hey? It says a concrete has to be 5 centimeters thick. We want to know the volume. So are we dealing in centimeters or are we going to deal in meters? All right? Well, we're not 100% sure. The question doesn't tell us. So as an examiner, we would have to accept both answers. So you could decide I want my answers in meters, or you could make your answer in centimeters. Sorry, meters cubed, hey? Or centimeters cubed. I'm going to make it in meters cubed. It's going to be easier to change the centimeters to meters. So I've got 355 meters squared times. Now, how many centimeters in a meter? There are 100. So I've got to take this 5 and divide it by 100. Why divide it by 100? Because I'm going to get a lot fewer meters than I do centimeters. So we're dividing it by 100. So let's do that on our calculator. We got 355 meters squared multiplied by 0,05 meters equals. So out comes our calculator. And we say 355 multiplied by 0.05 equals, and my answer now is 17,75. 17,75 what? Meters cubed. That's how much concrete I need to plaster the walls of my pool. In other words, let's try and get a picture of this. If I got a box 1 meter long, 1 meter wide, 1 meter high, I would need just under 18 of those boxes filled with concrete. And then I would take that concrete and start plastering the side of the wall. And I'd take more concrete out the box and plaster the wall. Eventually one box would be finished and I'd bring another box, take the concrete out and plaster the wall. Take some more, plaster the wall. Take some more, plaster the wall. And eventually I would have now plastered the whole wall. But I would have needed just under 18 of those boxes. So 17,75 meter cubed of concrete is what I need to concrete that whole swimming pool. And I think our time is nearly up. I can't believe it, and we still have question 1.
I know, hey? I can't believe it. Okay, so guys, if there is anything that you do not understand that Peter has gone over, please post it on the page, and we'll see if we can get to you later on the page. Also, Mindsetters, what we like to do is we like to help each other out. We're a community of Mindsetters. This page is not only for us, it is also for you. So get chatting, and if you do see a post there that you know the answer and you think you can help somebody out, please, please do. It's very, very important. And I want to give a big up to all of the mindsets that were on the page today, all of you grade 11s, and some of you aren't even grade 11s. We've got Mosa, We've got Dr. Takalani. We've been having such an awesome time on the page. That's facebook.com/Learn Extra. Also on Twitter @Learn Extra. Thank you, grade 11s. We had such an amazing show. Grade 12s, we'll be seeing you next. And have an amazing, amazing Women's Day, all of you. Big hug. Bye, guys.